And well, it took me a while to get it up last night because I had nothing but technical difficulties. The complete worked out solutions for the review are available. They're way down at the very, 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 very bottom. Underneath all the answers, there is a link to my complete worked out solutions. So you can see how I approached each of these problems to get the answers that are here in green. What are you guys interested in seeing or talking about? Again, whether it's from the review, whether it's from the homework, whether you want a problem that's similar to, what do you guys want to talk about and look at? Anything? But I give you guys about 4 or 5 minutes to see what questions you have, and then we'll come back and I'll go through anything. If you think of any in that amount of time, just let me know, okay? All right, so number 12. A solution of ethyl alcohol that is 75% alcohol by weight is to be used as a bactericide. The solution is to be made by adding water to a 95% ethyl alcohol solution. How many grams of each should be used to prepare 400 grams of the bactericide? So of each, the two things that are going to be mixed together are the 95% ethyl alcohol solution and the water. Those are our two unknowns. So those are going to be my two variables. So I'm going to let x equal the amount of the 95% solution. And I'm going to let y equal the amount of water. There are two things that I want out of my final product. I want it to have a 75% concentration. And I know that I want to end up with 400 grams of it, so I have a volume amount that I need. So here's my total volume. Since those are my end goals, I'm going to use those to write my equations. So I need an equation that is about volume. Volume is just number of grams of this together with number of grams of that gives me a total of however many grams. So I'm going to take the 95% ethyl alcohol solution. To that, I'm going to add water. And I want a grand total of 400 grams of that. So that is one of my parameters. The other parameter here is the concentration. And when I write an equation for the concentration, each piece of this will follow a very similar pattern. Just like up above, it was grams plus grams equals total grams. For the concentration, I need the percent times the amount plus the percent times the amount. This will tell me how much alcohol there is in each of these pieces. Since they've been given to me as percentages, I have to use the percentage times the amount to figure out how much alcohol is actually present in this. So for the 95% solution, I have 0.95, and then the amount of that is what my x variable is representing. How much ethyl alcohol is there in water? 0. So the percentage of alcohol that is present in the water is 0% times y. I want to end up with a final product that has a concentration of 75% times the 400 grams. So now I have my two equations. This concentration equation cleans up pretty nicely, and it alone will tell me almost everything I need to know. Because of this piece right here. 0 times y, what's going to happen to that whole variable in this equation? Yeah, it's going to cancel out. So I'm going to end up with 0.95x equals 0.75 times 400. Yep, 0.75 times 400 is 300. So I have 0.95x equals 300. I'm going to have to do some dividing here, and you guys don't get calculators on the test tomorrow. So I'm going to go ahead and multiply both sides by 100 so that I don't have to work with decimals at all here. You don't have to do that. If you want to do decimal division off to the side, you're welcome to. I tend to find it easier to work with whole numbers when I'm doing division rather than decimal amounts. So I know that x is going to be 30,000 over 95. And now I need to actually divide that out. Any answers that we get that aren't going to come out to be whole numbers, we want to leave these in forms of fractions unless we're talking about money. Although again, on the test, because you don't have calculators, if you leave something in fraction form instead of decimal form, I am perfectly okay with that. It does need to be completely reduced though. Is there anything that you know of that will go into both 30,000 and 95? 5 will go into both of these. So I'm going to reduce top and bottom by 5. On the top, that's going to be 6,000. What do I get on the bottom? 19. What goes into 19? Nothing really, right? So I would leave my answer like this. I can't reduce it any further. If you want to take it out to its decimal form, you have to give me at least 3 decimal places. But you're going to waste time on the test taking it into its decimal form. Reduce it and leave it like that. Each of these questions, you want to make sure that you are giving a full and complete answer while not doing more work than you need to. If you're unsure about what your final answer should look like, or if you've taken it far enough, ask me. I'm happy to let you know whether you need to take it any further. Morning, sir. We're going over question number 12 in the review packet right now. All right. And this would be grams. So what did we just find? X, which stands for what? Yes. So 6,000 over 19 grams of the 95% solution. And we still need one more piece, right? We need to know how much water. How can I figure out how much water? What can I do to figure out how much water is needed? What do we know about our final product? What'd you say? We need it to add up to be 400 grams. This isn't a simple subtraction problem like I would like it to be if it was a whole number, but I can still do this subtraction. So y is supposed to be equal to 400 minus x, and we just found what x is supposed to be. So I'm going to subtract 6,000 over 19. That means I'm going to need a common denominator here. What should my common denominator be? 19. So I need to take 400 times 19. That's almost 400 times 20, right? Y equals, I need this over 19. What is this going to come out to be? What's in my numerator? Can do it off to the side if I need to. I can multiply those together. 0, 0, then this would be 36, 7,600. So then I subtract those two. How much water do we need? 1,600 over 19. So I need 1,600 over 19 grams of water in order to make this solution. Do you guys have any other questions about this particular problem? Remember, on story problems, you do need to have a sentence written at the end telling me, like, actually answering the question. How much of each are needed? I have listed how much of each are needed, and I have indicated which one goes with which variable. You okay?
Yeah.
All right. What else would you guys like to look at? Which one? 14, absolutely. In case you guys missed it, 13 is straight off the story problem quiz that we did. Like, it's the exact same problem off the quiz. Number 14, the population. How are they measuring the population? In thousands. So off to the side, that means if P equals 1, then the population is 1,000. Does that make sense? They're measuring it in thousands, so the number that they report would then need 3 zeros at the end. The population P in thousands of a small town is expected to increase according to this formula. So that looks pretty important to me. I'm going to recopy that. P equals 15 plus the square root of 3t plus 2, where t is the time in years. When will the population be 20,000? They gave me the population amount, so what is P? What am I putting in for P?
20,000.
How much? 20. I'm putting in 20. Remember, up at the top they said population is being measured in thousands, so if they say P is 1, that's a population of 1,000. If we know that the population is 20,000, then P is 20. So I'm going to put 20 in the place of P. Then I'm going to subtract 15 from both sides. So I have 5 is equal to the square root of 3t plus 2. T is underneath that radical. I'd like to get it out. What do I need to do to get the t out from underneath the radical? Square both sides. Squaring and square rooting cancel out on the right. So I have 25 equals 3t plus 2. Subtract 2 from both sides. I get 23 equals 3t. Divide both sides by 3, and that's not a whole number. So in 23/3 years, is there another way that I could write 23/3 that might be more meaningful to the person reading this or asking the question, David? 7 2/3. So So in 23 1/3 years or 7 2/3 years, or I can even think of another way of describing that. 2/3 of a year, 8 months. So, or we could say 7 years, 8 months. And the population will be 20,000. You do not have to give me all 3 of these. Give me 1. 23/3, did you answer the question? Yes, you did. If I gave you a calculator, could you give me an accurate decimal approximation? Yes, you could. I didn't ask for the answer back in a specific form. I didn't say write your answer as a mixed number or tell me in terms of years and months. If the directions say something along those lines, then you would need to pay attention to that. But in the absence of those directions, 23/3 would be perfectly appropriate. Make sure you're including units with that, though. One thing I definitely want to point out while we're talking about some of these things, up at the top of every quiz, there has been some detailed directions as far as how your answers should be given back. Please take the time when you come in tomorrow to start the test to read the directions up at the top so that you understand. Like, I don't put on every single question, make sure to fully simplify, make sure to fully set. That is just an understood on all the problems. So read up at the top how you need to leave your answers and for any other parameters that might be important there. What else would you guys like to look at? Yes, ma'am. 2C, absolutely. Number 2, part C. All right, so I have this first set of parentheses that is being cubed. So whenever I cube something, that means multiplying it by itself 3 times. So I'm just kind of thinking about that in my head. So if I did -2 times -2 times -2, that is -2 cubed. If I do p squared times p squared times p squared, that's going to be p to the 6th. And if I do q times q times q, that's q to the 3rd. Morning. Come here. Same kind of thing for the fraction. We are multiplying it by this fraction over here. My numerator would be p squared. My denominator would be 4 squared. Sorry, let me change this up. P squared over 4 squared. And then this would be q to the 4th here. So I'm multiplying these pieces together. The piece that's over off to the left, I'm going to think about that kind of like it's a whole number. I can take anything and turn it into a fraction by doing what to it? Yep, putting it over 1. And the way I multiply fractions together, top to top, bottom to bottom, straight across. So up in the numerator then, I would have -8, that's -2 cubed. I would have p to the 8th and q to the 3rd. Down in my denominator, I would have 16 q to the 4th. I'm actually going to bring that up just a little bit higher so that I have room to reduce it. -8 over 16, will that reduce? -1/2. So I have a negative, it's going to have a 2 in the denominator. I'm putting the negative out in front. You can also put it up with the numerator. That's perfectly appropriate. Will anything reduce with p to the 8th? Nope. So I'm just going to have p to the 8th in my numerator. What about my q's? Will they reduce at all? Yes. What am I going to have? Just q. Top or bottom? Bottom. There's more q's down there so that when I reduce it, there will still be q's in the bottom, but all the ones in the numerator have canceled out. 2F, absolutely. Before I scoot on to that, does anybody have any questions about 2C? All right, let's go look at 2F then. We have a cubed root here. Don't miss this piece. It's not sitting up quite as low as I'm used to, but it is still a cubed root. Anytime I have a fraction underneath a root, I can split it up into numerator and denominator, each under that root. So this is the cubed root of x squared over the cubed root of 9y. Can I simplify the cubed root of x squared at all? No. Cubed root of 9? No, I could do square root of 9, but not cubed root of 9. Cubed root of y? No. Am I allowed to leave a radical in the denominator? No. I need to rationalize this denominator. A lot of people that I saw working on this did something that I totally understand, but it ends up making more work for yourself later. So when I have a cubed root, if I don't want a root anymore, I need something that is cubed underneath it, like z to the third power. That would simplify to just be z, right? So I want something cubed and something cubed so that when I take the cubed root, I can get rid of that root and the exponents on it. So I want to end up with y to the third here. I'm going to start off talking about the y. I want y to the third power. I currently have y to the first power, right? So what needs to be in this cubed root that I'm going to multiply it by? If I put y to the third power here, y to the third power, y to the first power, that's going to be y to the fourth. That's not going to totally cancel out. I want to end up with y to the third power. Y squared. Because when I take y squared times y to the first power, I'm going to get y to the third power, which is what I'm looking for here. We have to do the same thing top and bottom. And then we get to the tricky piece. 9. Here's what I saw a lot of people doing when they were working on it on their own. And again, it's not incorrect, but it's going to create more work for you. So I'm going to demonstrate what I saw first, but don't copy this down. I saw 9 squared. 9 times 9 squared would give me 9 cubed, right? And that's going to cancel out. That sounds perfect. If I do that, it means I'm going to have to simplify a radical and reduce my fraction at the end. There is a faster way. What do you know about 9? It's a perfect square. 9 is what times what? 3 times 3. So I could rewrite 9 as 3 squared. So I have the cubed root of x squared over the cubed root of 3 squared y. I'm going to think about it this way instead. If I write it like that, what do I need to multiply by in order to get 3 cubed? I already have 3 squared. What would I multiply by? 3 squared times what gives me 3 cubed times another 3. So here's what I'm going to multiply by. Make my stuff a little bit smaller so that it fits on my screen. So up in my numerator, I'm going to have the cubed root of 3 x squared y squared. What will I have in my denominator? Yeah, just 3y. Because when I multiply this together, I'm going to get the cubed root of 3 cubed and y cubed, which is just going to give me 3y. So that numerator, cubed root of 3x squared y squared over 3y. The problem with multiplying by 9 squared is that 9 squared, 81, has a perfect cube in it. And so then I would need to simplify that radical. If you have 9 squares so that it turns into an 81, you would have to simplify that piece. By identifying that 9 is 3 times 3, I don't multiply by too much, and so I don't have to reduce at the end. What else would you guys like to see or talk about? And again, if it's something you want to look at one that's like a problem on here and you want me to make one up, I'm more than happy to do that also.
You do
5A, absolutely. Yes, we can. All right. I have my numerator, which contains a fraction. I have my denominator, which contains 2 fractions. Joy. So I have like fractions inside of fractions. I'm going to rewrite this in a way that doesn't make my head hurt. So I have x plus 2 minus 3 over x plus 4. That's the numerator. It's being divided by this stuff in the denominator. X over x plus 4 plus 1 over x plus 4. I'm going to write it out as a division problem like this so that I'm not working with fractions inside of fractions inside of fractions. In this front piece, I know I'm going to need a common denominator underneath the x and underneath the 2. So I'm going to put them each over 1. And I'm going to multiply them top and bottom by that common denominator. What is our common denominator here? X plus 4. So I'm going to multiply by x plus 4. I have to do it on the bottom also. I can't make anything cancel here because I don't have an equal sign. The only time I can make things cancel is when I have an equal sign. So I have x times x plus 4 plus 2 times x plus 4 minus 3, that one already had a denominator, all over my common denominator of x plus 4. And that's being divided. These guys already have a common denominator. So I can just add my numerators. X plus 1 over x plus 4. Back over here, I'm going to distribute so that I can combine my like terms together and clean this fraction up. So I have x squared plus 4x plus 2x plus 8 minus 3 all over x plus 4. I want to talk about this for a minute. If I am dividing by a fraction, that is the same thing as doing what? Multiplying by the reciprocal. So instead of dividing by this fraction, I am going to multiply by the reciprocal. And when I flip that fraction over, I see something really nice happen. Yes, these x plus 4s are going to cancel out. Make this just a little bit smaller so that I can bring some more work around here. So I would have x squared plus 6x plus 5 over x plus 1, because we multiply straight across. Yes, ma'am?
So if there's like an x, like say there's like an x minus 2 in the top equation, and an x plus 2 in like the denominator, do they cancel?
If they are factors, yes. Yes, in this case, the only things in those numerators and denominators, so it's 1 times that, so that would be a factor of my numerator, yes. What I can't do is I can't, hold on just 1 second here. Let me get that out of the way for a second. I can't cancel like x with x. Those aren't factors because they're being added to something else. But if I have a whole factor, yes, I can do that. Factors are things that are being multiplied together. So like this right here is supposed to get multiplied to this over here. So those pieces are being multiplied. Division can cancel out multiplication. So that's why I'm allowed to cancel those pieces. Fantastic clarifying question. Thank you for asking that. Can I simplify this any further? Yes. How does that numerator factor? X plus 1, x plus 5 over x plus 1. Can I reduce that? Yes, this is a factor. It is being multiplied to the x plus 5, so division can simplify that. I can reduce through that. My final answer here would just be x plus 5. What else do you guys want to see? We have almost 10 minutes left. Yes, ma'am. Another completing the square problem. Absolutely. The one that we have on our page is question 6, but I'm going to do another example. All right, so I'm going to do 4x squared minus 8x plus 2 equals 0. And we're going to solve this by completing the square. First thing I want to do is this c value gets kicked to the other side. So I'm going to have 4x squared minus 8x equals negative 2. I do not want a leading coefficient. I'm not going to pull it out as a GCF. I'm going to divide it out of everybody. When I'm being asked to factor, that's when I need to worry about hanging on to those GCFs. I've been asked to solve. That's the same thing as finding my x-intercepts. I can divide everybody by this leading coefficient, and it does not change the location of my x-intercepts. So I have x squared minus 2x equals negative 1/2. And now I'm finally ready to do the completing the square step. I'm going to add something over here on the left. If you do something to one side, though, you have to do the exact same thing to the other side. So I'm going to add something to both sides here. All right. To figure out what I'm going to add, B remember this right here is 2AB. If I want just B, I need to divide that by 2 and by A. So I'm going to take negative 2x. I'm going to divide that by 2x. I'm always dividing by 2. I'm not dividing by 2 here because I had a 2 in my numerator. I'm always cutting it in half. So that's going to cancel. So my B value is negative 1 here. I don't want B on these two lines. I want B squared. Because I am trying to get this left-hand side to be a perfect square trinomial. I want a squared plus or minus 2ab plus b squared. I'm trying to figure out what this piece is right here. What is negative 1 squared? 1. So I'm going to add 1 to both sides. So I have x squared minus 2x plus 1 equals 1/2. Why did I want to force it into this form right here? A squared plus or minus 2ab plus b squared. Aiden. Yes. This is a perfect square trinomial. When it factors, it's going to be x minus 1 times another x minus 1. So that is x minus 1 squared. That is exactly what I wanted to happen. It should factor to be something times itself. That is our goal when we are completing the square. We had to figure out what that value was that would finish that off. All right, and that is equal to 1/2. Right here, I see a lot of people start to go backwards because we're so used to looking at something squared and I ask you to expand it. Right now, we are trying to solve it. We just worked really hard to make a perfect square trinomial. How do I undo something that's been squared? Square root it. So I'm going to take a square root of both sides. So over on the left, I have x minus 1. On the right-hand side, I have positive or negative square root of 1/2. Bring my work over here again. What do I need to do to get the x all alone? Add 1 to both sides. So I have x equals 1 plus or minus the square root of 1/2. Can I leave that as plus or minus the square root of 1/2? I have to rationalize that denominator, because that is exactly the same thing as saying the square root of 1 over the square root of 2. So I'm going to rationalize my denominator here. So I have x equals 1 plus or minus the square root of 2 over 2. Still have just a smidge of time. Yes, ma'am.
Can we do 11A?
11A. Yes. We're going to rationalize the numerator, so I need to multiply by the conjugate of my numerator. So 1 plus the square root of 3 plus x over 1 plus the square root of 3 plus x. Be careful in your numerator. We have conjugate pairs here. So when I distribute, I'm going to end up with something that looks like a difference of perfect squares. 1 times 1, I get 1. My middle term is going to cancel out, and I am going to subtract the square root of 3 plus x times the square root of 3 plus x. I have to distribute that subtraction to both of those pieces. Down on the bottom, I'm just going to leave this looking like a whole hot mess for right now. I am absolutely not going to distribute here because I am desperately hoping that something will cancel. If nothing cancels, that's okay. I can still leave it in its factored form and call it my final answer. The directions did not say I had to fully distribute everything. The directions said I needed to rationalize my numerator. So up in the numerator, I have 1 minus 3 minus x over this horrendous looking denominator. What can I simplify in that numerator now? One minus 3. So I have negative 2 minus x over that horrid denominator. What do you notice about both of these pieces? They're both negative, so what can I do to it? I can pull a negative 1 out. I'm going to pull a GCF of a -1 out of here, and that would give me 2 plus x. Why do you think I wanted to do that? Yes, that is exactly the same thing as x plus 2, and so that's going to cancel. So I would have -1 over 1 plus the square root of 3 plus x. I'm going to post the video from class today. I also teach the exact same class second period, and I'm going to record that video and post that as well. So you might check out that video tonight as you're studying. Please feel free to put me on fast forward. I don't mind sounding like a chipmunk. David, did you have a question that you wanted to go over?
Yeah, I just want to know what it meant by expressing the form A for number 8.
For number 8, yes. When it says to express in the form, oh, that should be plus. That's a typo. Thank you. My apologies. Plus sign is on the same key as the equal sign. I wish I could say that's the first time I've ever made that typo, but it's not. So, please make sure on any questions like number 8, that means if you end up with like 2 pieces in a numerator and a part in the denominator, you do have to distribute that division. So you would never want to leave something like -1 plus 3i over 2. To get full points, you would need to write it like this. That is the form of a plus bi. Do not leave it like this. Right. Yes, sir. 9D. Yes. I'm going to get a 0 over here on the right. 10x squared plus 11x minus 6 is greater than 0. Factoring this guy, I need 2 numbers that multiply to -60, and add to 11. So that's going to be 15 and -4. So I'm going to use my grouping. You're welcome to use an area model, a box. So when I make my groups here, I've got 5x that I can take out. That would leave me 2x plus 3. Almost forgot my 2. And from the second group, I can take a -2 out here. That would leave me 2x plus 3. So I have 5x minus 2 and 2x plus 3. I want to know where that is greater than 0. So here's where I make a sign chart. My zeros are going to be -2/3. Sorry, -3 halves. -3 halves and 2/5. And I'm going to have a result row. Come on. And I'm going to do my positives and negatives, knowing that I'm looking for the positive quadrants here. Please feel free to send me messages tonight. Also, once again, homework, homework, homework. Anything you haven't done, it will both help you study and it will help those grades go up to 100% if you have not turned them in yet. Have a great rest of your day, guys, and happy studying.